So our next question is going to be a math question. This question, they are asking us to simplify this equation. 2x plus 4 divided by 3x plus 6.
Divided by 3x plus 6. Okay, I will take this one. This is one of my favorite things to teach about, actually. And I think it's because it combines my middle school background in teaching fractions, and it combines it with a lot of the upper level algebra. So first thing I want to do before I actually get into this is I actually want to show an example of simplifying fractions, just because the concepts that you use when you simplify fractions apply to the same thing when we work with what are called rational expressions. And this is a rational expression. So I'm just going to pick, let's see, we'll say 10/12, okay? So if we wanted to simplify this, one of the ways that we could do this, and this is not typically taught this way, but one of the ways that we could do this is by factoring both the numerator and the denominator first. And I'll show you what happens when we do that. So if I factor the numerator and the denominator, actually, you know what? Let me back up. I thought of something different. So if typically the way that this is taught is by finding the greatest common factor, or finding something that can both numbers, numerator and denominator, can be divided by. So for example, this can both be divided, 10 and 12 can both be divided by 2. And so that would give us 5/6. Now, by doing that, and part of the reason why we can divide by 2 over 2 is because 2 over 2 just is equivalent to 1. So anything over itself, anything over itself just equals 1. And when we divide by 1, we're not changing the value of something, we're just changing what it looks like. So that's why we're allowed to do that. Now, the same goes for multiplication. When I multiply something by 1, I also don't change the value of it. So what I can do instead, if I wanted to, is I could factor the numerator and the denominator. So thinking of 10, it's the same thing as 2 times 5, and 12, if I were to do a factor tree of that, these are pretty common things. I'd get 2 times 6, and then breaking that down, I'd get 2 times 3. So I'd say 2 times 2 times 3. Oops, sorry. And same idea is multiplying. So see, this 2 over 2 is multiplying that fraction. So 2 over 2 is the same as 1, is equal to 1. And 1 times anything is just itself. So these 2's are unnecessary in our fraction. So we would say that without these 2's, so we can cancel them, cancel factors that are the same, and we end up with 5 on top and then 2 times 3 on the bottom, which is 6. So that's another way to possibly to simplify a fraction, is by factoring it first and then eliminating factors that are the same on the numerator and denominator. So that's the idea that we're going to go at with this rational expression, is we're going to factor it first and then eliminate factors that are the same on the numerator and the denominator. There are a couple methods, I guess, to factoring, but one of the strategies to factor is by looking at both of your terms, or all of your terms, and finding something that's common between them, that you can divide them both by. So when I look at 2x and 4, I know that they are both divisible by 2, so that means that I can factor a 2 out of both terms. So when I factor a 2 out of 2x, so I'm basically factoring is dividing, right? So I'm doing 2x divided by 2, that just leaves me with x, and then I'm doing 4 divided by 2, which just leaves me with 2. There's my numerator, and you can check your work too. You can, I kind of sometimes refer to this as reverse distribution. It's like backwards distributing. So you could always check your work by distributing this 2 back in, just to see, does that equal what I started with? And yeah, it would. Then on the bottom, we can do the same thing. We're thinking of something common that goes into both 3x and into 6. And I know that 3 and 6 are both divisible by 3, so I'm going to factor a 3 out of both of those terms. So So the first one, I'm going to be doing 3x divided by 3, which just leaves me with x. And then the second one, 6 divided by 3, gives me 2. And same idea, you can multiply back together just to double check, did I divide this 3 out correctly? Did I factor that right? And we did. And then back to this concept over here, where I eliminated any factors that are the same on the numerator and denominator, I can do the same over here. Is this factor, x plus 2, is the same as this factor. In fact, if I just look at this whole thing, anything over itself, it just equals 1. So 2/3 times 1 is still 2/3. So what that means is that this fraction, or this rational expression, just simplifies to 2/3. So rational expressions and rational equations, they look really scary because, well, a lot of people dislike fractions. And then we are throwing letters in with fractions, and they look really scary. But if you know the rules and you know the procedures and what works and how fractions, just regular fractions, work, then you can just apply those to rational expressions, and they're really not all that bad.
Yeah, that's why lately I've been kind of working with my students on just fractions, even if we don't need them in my class, because I know later just understanding kind of the principles behind fractions and how they operate really helps you with those rational expressions, because I don't know, it just feels like a lot whenever you're not that comfortable with fractions.
It's so true. And kids always think, oh, I can just use a calculator. Why do I need to know this?
Right.
Well, it's because concepts later on in math require you to have that procedural background knowledge that will really actually help you out.
Yeah.
So